Welcome, welcome, welcome. Happy Friday or happy Saturday for some of you. So yeah, today's part 3 of reading the Nim Manual, the stream where we try to soak in the knowledge given upon us by the Nim creator. So let's get straight to it, where we left off. So last stream we finished at default values for object fields, and overall we were going through object variants and all those things. So today we're gonna start off with set type, which is, I believe, very powerful, yet sometimes, at least I have some trouble comprehending it. So maybe going over it again will help out a little bit, at least me or something. And maybe you too. That would be great. Alrighty. Set type. The set type models the mathematical notion of a set. The set's base type can only be an ordinal type of a certain size, namely int 8, 2, and 16 unsigned integers from 8 to, or byte or uint 16 character, or just overall ordinal subrange types, for example, range from -10 to 10. So it's basically a mathematical notion of a set, which is basically a set of numbers. I believe it's nothing other than that. It's just a set of numbers. It's not like a hash set where, in many languages, so think of a set like in JavaScript or something. Oh, that means that you have a list where values can be duplicated. This is not it. Here is basically a set of numbers, and those numbers can be in a set or not in a set, and that's it. Or equivalent. When constructing a set with signed integer and literals, the set's base type is defined to be in the range of 0 to default set elements -1, where default set elements is currently always 2 to the power of 8. The maximum range length for the base type of a set is max set elements, which is currently always 2 to the power of 16. So this, I believe, is like 255 possible elements. This will be probably, 16,000 something? Or is that... I don't remember which one this is. This is probably 65,000, yeah. Types with bigger range length are coerced into range from 0 to maxed set elements -1. Okay. The reason is that sets are implemented as high-performance bit vectors. Attempting to declare a set with a larger type will result in an error. So we define it as a set, and in square brackets we define type, or a range, I guess, and various other things. Note, Nim also offers hash sets, which you need to import with import standard sets, which have no such restrictions. Yeah, but hash set is more about containing various properties, which I guess can happen to be numbers as well, just like here. Okay. Sets can be constructed via the set constructor. Okay. Okay, so it's the curly brackets. So the curly brackets is the empty set. The empty set is type compatible with any concrete set type. The constructor can also be used to include elements and a range of elements. Okay, so we can define a tab like character set, which is just set of characters. So this is a set that can contain all the possible characters, and that's it. We create a variable for it, and we can set that the value is from A to Z and from 0 to 9. while character is probably the value from 0 to 255. So this constructs a set that contains the letters from A to Z and the digits from 0 to 9. Okay. The module standard set utilities provides a way to initialize a set from an iterable. So we can basically say my string to set. Oh, and it will basically probably construct something similar. Yeah, that's awesome. That's a quick way to count how many characters are there, right? Or not like how many characters there are, just what characters are in the string. I want to try that. So this is the unique characters, right? Oh, my string. So let's do hello world, okay? And that should be defined as a set of characters. There we go. So notification will be popping up nonstop. Sorry about that. The newest version of Nim and the Nim Lang server kind of messes things up a little bit. So let's do echo unique characters, and let's see what we get. Yeah, we're getting weird stuff here. Okay, so we've got a space, exclamation mark, H, D, E, L, O, R, and W. So the L's and O's are deduplicated. And the other, and that's it. Yep. That's that. We just got a set, and we can see that these are the curly brackets, so that suggests that it's a set. So these operations are supported by sets. We can have a union of sets, intersections, so I can see this is very mathematical. Difference, equality, subset relation, membership, so n, not n, if something contains. The cardinality of A, the set A, which is number of elements in A, okay? And include, which is, I guess, modifying. Yeah, so look at that. Union, this way, or a difference. This just returns a new value, right? But include or exclude modifies the set. All right. So if we will get any characters 1 and maybe any characters 2, and we're just gonna do Wallow 1000, right? So we can echo both of them, right? That should be no problem. Yep. First set and second set. And we can probably do add cardinality, and so be card, I believe. Okay, and therefore we can do let unique characters 3 will be the unique characters 1 plus unique characters 2. So this should be the union of those. And we can just do echo it. So because they share letters like L and O and a space, this shouldn't be 9 plus 6, which will be normally 15. The L, O, and the space are shared, therefore we have 15 different characters. So that's that. The same would be with difference. And difference, yeah, only 6. There you go. So this leaves those alone, okay? There's nothing that would change if we would put this, this definition up here. We'll run it, it'll be all the same. So, yeah, works the same. But we have the include and exclude. So if we would try to do something like, we could, for example, instead of this, we could do unique characters 1, include, and we could put in, do we do just one element? Oh, it's just one element. Look at that. So include is for just an element. So we could include, what would it be? A question mark in there, right? And that won't work because this isn't var, it's let. If we'll make it into variable, then it allows us. So include and exclude basically allows us to add or remove something from an existing set. But I wonder if we could do this. Will it compile? I mean, it seems to compile. So when we print it out, we should have this a little bit different. So let's try it. There we go. Cardinality and all the characters are combined here. All right, perfect. So all those work. So yeah, this is basically, it boils down to being a set of numbers that we can mark which numbers are there, which are not. And first, Caliph Kana says, hey there, hello to you too. I can see that you decided to join the stream. How are you doing? All right, so we went through basically an overview of the set type. Now let's move to bit fields because this is getting a little bit more interesting. Sets are often used to define a type for the flags or procedure. This is a cleaner and type-safe solution than defining integer constants that have to be ORed together. So enum sets and casting can be used together as in. So this is something I pointed out several times already because this seems to prop up in various tutorials. So I will go over it again. I would like to be reminded about it. Might actually use it somewhere in the Raylib stuff because this is often something that you could use for high performance or to save memory. Farah says, doing great. What about you? I'm doing great as well. It's Friday, so I'm happy. Alrighty, so let's take a peek at this. So we're defining my flag. Type my flag. This is the confusing part. Cint, a C integer or something. We're defining size of something. And then we basically define an enum that has A, B, C, and D. What I suspect the size means is that it's a basically the type behind the scenes of the values for the enum. But I recall testing it at some point and didn't make any difference, so I'm not sure. So we basically have this enum defined. And then what we can do is we can define a type that's a set of that enum. So basically, the set allows to be either A, B, C, or D, or any combination of those. Okay? So these are basically flags that could be assigned. So then we have toNumber. So we define a procedure toNumber where we take those flags and cast them into that C integer to just become a number, okay? So because these are just bits, really, is this thing in a set? Is it not? They're just literally bits, we can cast it to a number. And we can do the other way around. We can take that integer and cast it back to the set of those flags. And that's pretty much it. So we have a bunch of tests. So basically, if we'll try to convert an empty set to a number, none of the flags will be flipped. Therefore, it will be a bunch of zeros. Okay. We can probably kind of visualize it a little bit more for those that are not used to all the crazy bitwise logic, which, to be honest, I am not really used to it. It's not something that I really enjoy working with. But basically, this thing can be represented like this. So if we have an empty set of those 4 values, so it will be 0, 0, 0, 0, okay? So this binary into an actual decimal will be 0, okay? Behind the scenes, we know that this is using C integer, which I presume is a 32-bit number or something of that sort. I presume. I am not 100% sure. Not 100% sure. Can I do something like echo size of C int? Can I do that? Looks like I can. Let's learn it. 4. I guess 4 bytes. So that will be normal 32-bit integer, I believe. Yep. So, continuing. Oh, hello, CPN. CPN says, yeah, C int is usually 32 bits. It depends on the OS. So C integer is 32-bit, while if I would do echo size of integer, that should be 64-bit because I'm on a 64-bit system. So yeah, we've got 8 bytes. Okay, interesting. I guess C tries to be really conservative and try to make everything run the same way, no matter if you're on a 32-bit system or 64-bit system. What about 16-bit systems? Or 8-bit systems? Alrighty, so here basically we have the data is 0, 0, 0, 0 because all flags are 0. If we have A, we can think of it as only the A, the binary representations often, you can imagine that the first thing is the last bit. So instead of, by default we would have empty, but we added a one element. That's the first element. So it's the first one from the end. So this would be the value. In binary, this represents 1. What if we'll take D? 1, 2, 3, 4. So we'll have 1, 0, 0, 0. And because the first bit represents either 0 or 1, second is 0 or 2, each one is like power of 2. So that suddenly turns into 8 because we have 8, 4, 2, 1. While if we have C and A and C, we basically have 0, 1, 0, 1 because last one and the third one from the end. So this will be basically equal to, this represents 1, this is 2, and this is 4. So plus 4, we've got 5. So this is the thing that you often would do when you really want to save a lot of memory. Where, you have maybe a bunch of Boolean values, like should it be this, should it be that, and maybe combine it with some other number or it's something else. But often you can see it in high performance or, low memory situations where you have basically a bunch of flags. In this case, it could be, you know, I instantly have things that you might think of when making games, because that's the situation where I'm most familiar with it. So let's say that this will be entity properties, okay? And that will be an enum. Or let's say it's an object, okay? Let's say it's an object that we want to have some things. So normally that entity maybe it will be something like for that specific entity will be maybe name, which would be string or something, and then you would have a bunch of let's just make it health points and armor. Okay, so let's do enemy props. Okay, that's a little bit more relatable. We have name of the enemy, health points, armor, and then you would have maybe a bunch more, a little bit more things like can walk, right? Or can attack. Or maybe can fly. Whatever. What else would there be? Can walk, maybe can swim, and sure is boss. And maybe let's get one more, which would be sure, it could be a uint. It's a good point. If we're talking about saving memory, right? So let's say that we have all that. And here maybe instead of name, we'll have the ID, right? ID, which will be pointing at some reference to where we define the types of enemies. Or yeah, let's call it enemy type, okay? And that's that. So we have a bunch of those properties, maybe is boss or is stunned or something. Bunch of those flags. And suddenly, because how memory works, you would need to be either very careful how you arrange those, or maybe you just have 5 of them. The way memory works behind the scenes is that often when you want to store a single boolean, it actually takes up way more data in the background, like really in your RAM, because it needs to be, boxed in something that fits the other parts of the, layout of the whole object that you're defining. It's not something I know about a lot, but it's a relatively complex subject. So often, you would want to, it would be so much nicer instead of having a bunch of those booleans that probably each one will be 1 byte or something. We have 6 of them here. We can probably easily fit them in something smaller. So we can basically specify a type. Let me just, I can't do that. Let's just do spaces too, okay? Enemy flags. Sure, it will be enemy flag. Whatever, I'm doing it backwards. So we want enemy flag. We can probably ignore this whole thing, okay? Just for the sake of working on things normally. And we can just specify can walk, can attack, can fly, can swim, is boss, is stunned. We can specify all those in here. And then specify that we have a type of set flag. We could have it this way, we could do something else. So what we can do here is now we can just say flags, and that will be the enemy flags. So when using that, we can still quickly check if I want to, let's say I have enemy is, default enemy props, okay? I just have an enemy. I can still easily check if it can fly, okay? I can do if enemy dot flags No, yeah. Dot contains is boss. Okay. I can say, hey, it's a boss. I can still check for that. Or I could do the reverse, which was boss and enemy flags. You can do that. You can even do something more interesting because maybe some of your code is like, you know what? You need to make sure that only enemies that can only walk but cannot fly and cannot swim can do something. So you basically have a bunch of checks. Can swim is an enemy flags, and can fly is an enemy flags, right? You could have probably a bunch of that all the time. I wonder if we can just create a new set for that, but I don't know how, how performant that part is. Looks like you can't. So yeah, that's that. So let's say that your code often checks for multiple things, and that just stays the same. So what you could do instead is basically, you know what? I'm gonna... Maybe what I'm trying to say is wrong. I'm sure you could do constant would be whatever. Walk only check, and that we basically can fly and can swim. Okay, so we want to rule those out. So I believe we should be able to use one of those functions, right? Because we have to check if subset relation A is subset of B or equal to B. Okay, so we can say A is subset of B. So we should be able to do if walk only check is a subset of this. So we can check if those two can exist there. So that's another thing. But you can also do things with binary after you kind of mark things together too. So all right, so we can do a bunch of those things. And at the end, when you want to, the way it is being stored behind the scenes, it's basically as that number instead of something else. Or if you want to do it manually, you just convert it to a number. Hey, stored flags will be to number? Not really, but basically we do cast to integer the enemy flags, right? Or we can probably just do, we have 6 of them. Each flag is 1 byte, 1 bit. So I guess we could just do it as a byte, because we have less than 8 flags. And that's it. So that should be stored as a flag, or you can just do echo stored flags. And we'll see if that works. Store flags is 0. Oh, because we don't have anything set in the first place. But yeah, that's how we can store things and pack multiple flags into one thing, ensure that they are stored, as tightly as possible. And that's what this whole thing does behind the scenes. Yeah. So note how the set turns enum values into powers of 2. Exactly. If using enums and sets with C, use distinct C int. Yeah, that's the whole idea. If you're interacting with C language, just use the C int. For interoperability with C, see also the bit size pragma. What's that? The bit size pragma is for object field members. It declares the field as a bit field in C or C++. Okay. Okay, so we can see that if we define the field on an object, flag, something, we can set it's a bit size 1. And cuint, okay. So it will generate that unsigned int flag. And I guess this is how to align it in memory to kind of force things a little bit, possibly. I am definitely, I don't know. I don't use C nor C++. That's why I'm learning Nim. All right, give me a second. I'll be right back. Alrighty, I'm back. Sorry about that. Okay, so we got through the flags, and I actually got an idea for one more thing that I could imagine that could improve performance of some areas. Again, for example, in gaming or in graphics and some other areas. So let me just get rid of this example here. So let's say that we have a system of directions. It's often that something, you have a grid, and on a grid, something can move north, south, in 8 directions. So let me maybe draw it a little bit to make it more sense. Go to Excali draw, move away from this. So let's imagine that we have a grid. Okay, I'll just draw a few lines. Alrighty, we've got a grid. Alrighty, so for a specific cell in that grid, let's say that our character or something is right here in the center. It has basically, it can go north, it can go, east, south, west, or it could go in other directions, okay? That's something simple. So to represent a direction, we could simply specify that, we have type Uh, direction. Okay. And now be an enum. And we'll just say north, northeast, east, all the possible directions. It's 8 directions. Conveniently, I'd say. So now, where'd it go? All right, so now the thing is that maybe we want to be able to, we work on some kind of AI thing that, depending on the movement of the character or something, you basically want to start planning, different characters' moves or all the possibilities. Start to working with that. Actually, even better option would be to make it a little bit more like, let's say that. Gosh, to my mind, very specific situations come to my head right now. But what I'm trying to say is that we can actually define a set of all those directions to represent which directions maybe the character is actually able to move. Because let's say that all the way here is a wall, okay? It's a wall. And maybe there's another something here. Bam. Therefore, we know that the character can move only in those 3 directions, okay? So we could basically reach out for those flags again. So instead of having our character, okay, and having can move north or something. Yes or no, can move there, can move there. Bunch of those, or somebody else might think, you know what, I'm gonna make it that allowed directions, and that will be an array of the direction, and therefore we can check if later if we have let character we'll just create default character for now. So we have to check if the W was pressed, up. Can it go actually up? So we do if character allowed directions north, then do something. Okay. But in this way, it's very likely that weird things might start happening. And suddenly you need to check, okay, can it move up? Can it go down or something? A bunch of things. What one could do is, again, do basically, instead of being an array of directions, you just make it a set of directions. And this way we can assign that it can go there, can go or there. So we can say if north is in allowed directions. So from the usage perspective, it doesn't change much. What is the problem here? Type mismatch. Direction. Okay. We're getting weird errors here. What on earth is the problem here? We had contains, or where'd it go? Get in and contains. Direction.north. There's no ambiguity, so I am doing something wrong here. But one of those contains either this or that. Okay, I'm confused. I'm not sure what I'm missing right now. Yeah, we've got our set. And I don't think we need set utilities for this particular thing. Unless, oh, we probably need. Yeah, that's probably what it is. North and here. Oh, standard set utilities. Set utils. Hmm. That's not a problem. Character dot allow directions. Okay, I'm not sure why it's saying that. Can I run it? Port and not use set utils. And it just hangs in place. Doesn't even compile. Okay, we've got some weird problems. Okay, that works. So it's a warning, and then we have nothing else. I must say, I'm a little bit confused. Didn't expect that to happen. As in things totally not working. But the idea would be that suddenly all those are forced to be stored as one number, and therefore in the future, maybe you want to have some additional checks for, you know, if the character has specific combination of possible movements, then allow maybe some ability or something that happens, you know, that you can run only if you have, you know, a bunch of things possible. So you could basically define somewhere that you want to have, let's say, a lookup table for all the possible combinations. So you could literally make it in a way that you're gonna do direction combination lookup table. Okay. And you can basically specify it to be maps from one value to another one. That could be an array from something as simple as, in our case, it will be a byte, to maybe a set of allowed moves. Move type, okay? So let's define quickly some kind of move type. Move type, which will be maybe not move type, let's do ability type. Diagonal fireballs, okay? That'll be one move type. Another one would be a icicle cone. You should a cone of icicles in front, or a bunch of other things, and so on, right? So you could basically create a whole lookup table where you generate all the possible combinations of allowed directions, and that will be 255 total 256 combinations, so they will fit in an array. And for each of them, you might have defined like, okay, if we can literally take allowed directions, I mean, I would just need to do, sure, whatever, this is good enough. So then a feature you can say if, let's say you're checking if you can actually use the ability to, do the icicle cone. So if icicle cone, and then you take maybe there'll be abilities per direction, okay? And there's abilities per direction, and you take the current character allowed directions, you could be able to basically take me for this whole thing and have it already preset there. Therefore, instead of you checking like, okay, one by one, is this direction allowed? Is that direction allowed? Maybe something else. You already have the whole thing pre-computed, where the whole sets of allowed directions are turned into just small bytes, because it's just a bunch of ones and zeros, and you can just grab possible moves for that area with just one lookup, and that's it. Okay, that's literally it. For some reason, I'm getting a bunch of errors, and I have no idea why. Absolutely no idea why. Does it need to be literally specified as a flag? Direction flags. That would be the silliest thing ever. This works. I guess I'm doing some weird stuff here, and that's why. Who knows? Yeah, who knows? Ability type. Oh, that would be probably it. Well, this is not an error. This is an error again, so it doesn't matter at this point. But I hope this means something to somebody. All right, let's move on because I'm just blabbing at this point. Reference and pointer types. References, similar to pointers in other programming languages, are a way to introduce many-to-one relationships. This means different references can point to and modify the same location in memory, also called aliasing. Okay. Nim distinguishes between traced and untraced references. Untraced references are also called pointers. Traced references point to objects of garbage collected heap. Untraced references point to manually allocated objects or objects somewhere else in memory. Thus, untraced references are unsafe. However, for certain low-level operations like accessing the hardware, untraced references are unavoidable. Okay? So, traced references are declared with the ref keyword. Untraced references are declared with the pointer keyword. In general, pointer T is implicitly convertible to the pointer type. This is a lot here. We actually had a whole live stream just on this subject, so you can look it up if you want, deep dive into that subject. I will just roughly gloss over it. So, an empty subscript notation can be used to derefer a reference. The address procedure returns an address to an item. An address is always an untraced reference. Thus, the usage of address is an unsafe feature. And additionally, the access, a tuple/object field operator, and the array string sequence index operator perform implicit dereferencing operations for reference types. Okay, so the whole idea is that we can define, let's say, an object, okay, that has some fields, and then we can define a reference to it, okay? And therefore, let's say we created a node, and then we created, what we're doing here is basically creating a new value for it. The new actually creates a, yeah, because this is a reference, right? So we define a reference to a node, or reference to a node object. I know this is a confusing example to just put it here, huh? Let me rewrite it so that it's a little bit more easy to understand. So instead of doing this, let's make it node reference. This will be node object. So we define a node object that contains some data and reference to, you know, left element and right element. And we also define the reference to that. So you can think of a reference just as a value that points at something. The drunken alcoholic is back. Hello. I was about to write to you if you're doing all right, because you weren't here for a while. How are you doing? So basically, in other terms, we can scrap all that. We have our node object, okay? And that object has the data field and left, right, and all that stuff, okay? While what a node reference is basically a number that points at an actual object, okay? And even here, this left and right, they point at some other objects. So left, LE, is just some number, and right is some number. And they just point at some more objects. So this could point here, and this could point there. So we can label that this is a node reference. And this node reference as a type, it just means that during compilation, we'll be checking that, you know what, make sure that it's a reference to an actual node object, and do some additional checking up if everything stays, you know, safe, as in, you know, Nim will keep track of those objects for us so that we're making sure that we're not pointing at something that was already deleted or something. So that's that. Basically, those references will keep this object in memory for as long, because, you know, you can have other things point at it. There's no problem for you to have a bunch of other numbers pointing at it. But the moment all those references are gone, Nim garbage collection will realize that, you know what, we don't need that object anymore. Nothing's pointing at it. Nothing knows it exists anymore. Delete it. So that's the thing with those references. The drunk alcoholic says, I'm good. Unfortunately, work gets in the way of all the fun. That's too bad, but I hope you can have some fun times now for a few days, right? Okay, so now that we know about those references, we can see that let's just put it this way, this looks a bit more readable. We define a variable n, which is a node reference, okay? Right now, at this very moment, it doesn't point anywhere. It's literally nil. It's empty, it just doesn't exist. Yeah, but here, we're using the new, which means that we create a new object for it. And this is not on a stack, this is on a heap, somewhere out there in the cloud memory. It basically creates a new value for it. And then we can start setting. And you can see that we don't have to do this to, okay, because n is just that number, the kind of the reference to it. Those brackets would take the value of it, which is the node object, and then we could do the dot to get to the data field. But Nim allows us to just skip that part and not worry about it, okay? So that's that. Yeah, that's basically it. And just the important thing to realize here, that a reference is a number. It's just on a 64-bit system, it will be just int 64, just an integer. So sometimes if you want to save memory, you might opt in for using references instead of copying whole objects, as long as they are larger than, as long as the reference itself is smaller than the whole object. I mean, there are a bunch of other stuff going on in the background that Nim kind of hides and turns things into references automatically behind the scenes when it thinks that it's a little bit more optimal to pass things via reference instead of value. It kind of hides it away from you. But we're not gonna get into that because I don't understand it myself. So to continue, let's read. In order to simplify structural type checking, recursive tuples are not valid. Oh yeah, you can't make a tuple that contains itself. Yeah. Not for tuples. But for objects, hell yeah, you can do that. Likewise, the t equals reference to t is an invalid type. Obviously. As a syntactical extension, object types can be anonymous if declared in a type section via the ref object or pointer object notation. This feature is useful if an object should only gain reference semantics. So, in here, notice that we create that node, which is a reference to an object, and we define fields here. That means that we can't specify that something is of a type node object or something. We can only specify that it's a reference. I mean, there are ways around it, but let's not get into that, all right? To allocate a new traced object, the built-in procedure new has to be used. To deal with untraced memory, the procedures alloc, dealloc, and realloc can be used. The documentation of the system module contains further information. So that's the thing. With references, we can use things like new to create, to tell them, hey, create me a new space in memory for that object, and give me a reference to it or something. So here we saw that we created it by calling new and giving it a reference to it. So what this new does basically is, you can imagine a proc new, right? That takes a node reference, and what it will do is basically is gonna reserve some memory for the node. And then it's gonna say, you know what, that n, that value is, it could be even literally that. Create a new node object and put it as a value of this thing. You could literally do that because we're specifying that we're setting it as a value, not something else. So yeah, sure, you can think that it's in that way. I'm sure it's a bit different, but that's that. But the other way to approach it here is something that I personally would do a little bit more often is, let's say we'll simplify it. Variable n is new node reference, and was it that way? No, it's not. Oh no. Oh, something like this. Yeah, just without the parentheses. And there you go. That's an equivalent. This will return the reference that you can assign here. So that's the only difference. I believe it calls kind of the same thing, although I'm not sure. Actually, all those news and other additional things are defined in the system. Inside the system standard library. But for pointers, because there's nothing stopping you from defining, you know what, that you want to have an extra type, which is node pointer, which is pointer to node object. You can do that. But then, if you want to have, let's say, RP is new node pointer, because we called new of what type or something, we actually should new node object, I believe, right? Yeah. It returns reference object. Well, if we give it type, even though it's the same thing, interesting. But here it wants to create a reference to a pointer, which is kind of funny. Why not? But with pointers, unfortunately, it's a little bit different. We will need to specify that this is a node pointer, right? And then we would actually need to assign some data to it. We will basically need to say that, you know, do this and that. So we will basically need to do this whole alloc and the alloc. And to take a quick glance, we can probably search for alloc. Or maybe here. System, and we have a bunch of different allocations. But let's say that we're gonna pick what? It returns a pointer itself. Okay, so yeah, alloc. I forgot how to do that. Wow. Can we do that? I don't think so. I forgot how to deal with pointers. I don't know if we're gonna get an example here. Oh, I'm a mess today. Sorry about that. Yeah, but basically we would need to manage the memory ourselves, because at this point, the Nim isn't aware if we're creating new memory or maybe we're pointing that pointer to something that already exists. We simply don't know. Oh, I mean, we could do that, you know, var pointer is a address of the value of n, okay? It's a pointer to node object. If we would do this, it will be pointer to a reference, which would point at the number, which is a reference. But we want to point at the value, right? And that will allow us to change the value itself if we want it. But Nim isn't aware that we're doing something with it, okay? So if, let's say, at this point, we would say, you know what? N is nil, right? We just remove that pointer or whatever. But we still have this reference. So in theory, we're still pointing at the same spot in the memory. But the data might not be there anymore because Nim just garbage collected it, because none of the actual references point there anymore. So that's why to work with pointers, you need to manage your memory manually. So now let's read up about nil. If a reference points to nothing, it has the value nil. Nil is the default value for all reference and pointer types. The nil value can also be used like any other literal value. For example, it can be used in an assignment like my reference is nil. The referencing nil is an unrecoverable fatal runtime error, not a panic. So yeah, they're just saying that, just like here, we just set that reference to nil, so it points nowhere. Therefore, that node object that we had it pointing at will be basically scrapped by Nim. So if we would do p.data as 10, this might actually fail because that data might not be there anymore. You know, we don't know how fast Nim will actually collect that garbage or not. But what they're also saying is if you're gonna say nil and try to do something, this is gonna be an error. You can see that during compilation, wow, request text document symbol failed. Wow, the whole server, Nim server crashed. Oops. But yeah, this is gonna just crash your program. So a successful dereferencing operator, like this one, implies that P is not nil. So basically, if by accident you have a nil, your program will crash. This can be exploited by the implementation to optimize code lag. So something like this, we have P and the value, no, its value.field is 3. You don't have to check for nil, because if that worked, you already know that it's not nil. Because if this was nil, this would just stop already here and you wouldn't get here in the first place. Okay? So you can just do this and still worry that this was a nil in the first place. This is not comparable to C's undefined behavior for dereferencing null pointers. Okay. So that's that. And then we have mixing garbage collected memory with pointer. Special care has to be taken if an untraced object contains traced objects like traced references, strings, or sequences. In order to free everything properly, the built-in procedure reset has to be called before freeing the untraced memory manually. Okay, so we have our type data, which is a tuple that contains x, y, which are integers, and s string. Allocate memory for data on the heap. So we basically say, allocate enough memory that will fit the data. Okay, so this is a little bit more manual. And then, at the end, cast it as a pointer to data. Oh, because alloc, what it does, it takes just a size of how much memory you want to allocate. All the returns is a type pointer, literally the word pointer. So we could just, grab this and kind of dissect it a little bit. Let's just get our type data. Let's just copy the whole thing, okay? So if we're gonna do this, we could just take it out of here and do var a pointer is this, okay? So at this point, can we restart the Nim suggest? Probably not. Okay, so this is literally type pointer. Because remember, a pointer is just a number. It doesn't contain any information what kind of data it's holding. So this is the closest you can get to C or C++, where you just have pointer, hey, that's a number. You need to remember what kind of data it points to. So just for our, security, so that the compiler can help us out, we can take that pointer and directly cast it as a pointer to data. Okay? Now it's gonna be happy, and now we can easily do all this stuff. Like create a new string on the garbage collected heap. Bam. Then we have to tell the garbage collection that the string is not needed anymore. So we have to reset the string. And this is because string is supposed to be garbage collected. I believe we're getting a reference to it here, right? We're not actually storing the array of characters. We just store a reference to that string. So we need to tell to reset it before we free the memory for the whole data, okay? That's my understanding of it. Yeah. Without the reset call, the memory allocated for the DS, the string, would never be freed. The example also demonstrates two important features for low-level programming. The size of proc returns the size of a type of value in bytes. The cast operator can circumvent the type system. The compiler is forced to treat the result of the alloc0 call, which returns an untyped pointer, as it would have the type pointer data. Casting should only be done if it's unavoidable. It breaks type safety, and bugs can lead to mysterious crashes. Exactly. So just be careful out there. Note, the example only works because the memory is initialized to 0, alloc0, instead of the regular alloc. Because the regular alloc, it's initialized to 0, alloc0 instead of alloc. So alloc0 basically kind of clears the memory. You're defined that, okay, I need that much memory, and what alloc will do, it will clear it all to zeros, so that if something remained there, it will, be cleaned up. So d.s thus is initialized to binary 0, which is the string assignment, which the string assignment can handle. One needs to know low-level details like this when mixing garbage collected data with unmanaged memory. So yeah, it basically gets complicated. You start to learn more about how Nim works behind the scenes. And I'm not that excited about that personally. Although I'm slowly learning, getting better at figuring out, low-level details of things. So now let's start getting in some more interesting things. Because, references and pointers, that's, nothing crazy interesting. Procedural type. A procedural type is internally a pointer to a procedure. Nil is an allowed value for a variable of a procedural type. So here we have an example that we have a proc print item and takes an integer x, okay, and does something. CPN says, I'm not a big fan of mixing garbage collected memory and low-level memory access. Yeah, it's not the greatest choice, but you can do that. That's the thing. They're just making sure that you are aware that you need to call reset on it. That's all it is. If you want to go that route, you can. You don't have to do like crazy gymnastics or something. It's just you're left on your own at that point. Alrighty. So we have this procedure, and then we can say we define another procedure for each that takes a procedure that accepts an integer. Okay. C declaration. Huh? I don't think this is required here. So this way we can basically pass this print item into for each because their types match. Okay. So this is basically defining what kind of function will fit in here, and we can pass functions around. And here it won't work because calling conventions differ. How so? I guess this messes it up. I want to see that. Echo X, okay? And here we just call it 3 times, right? Why does it fail? Okay, the expression for each print item. Print item, the proc is GC safe. Expected one of those, so it expected something that is C declaration while normal is GC safe. So if we remove this, it should work. Again, I'm not a big fan of putting in those. Yeah, now it worked. So here in the manual, I kind of don't like it because you're learning about procedural type for the first time. It's the first time you're seeing it, and suddenly you have this mixed in. And if not that, everything would work. But this hasn't been defined yet. Like, what is C declaration? Is it anywhere else in the whole thing? Come on, go away, notification. C declaration. The C convention means that the procedure shall use the same convention as the C compiler on the Windows. So yeah, it's pragma. Yep, bunch of weird stuff. Bad example. Let's look at the other example. We have type on mouse move, okay? And that's a procedure that takes X and Y as integers, right? So something that we could call, like when the mouse moved, we give it the position of the mouse and it can do something. And we mark it as a closure. I guess that's the idea here. That's how we can define it, maybe. Not sure. Forgot about closures. And then we actually define the procedure here, like an example on mouse move, this and that, and has default calling convention, yep, and echo some stuff. And therefore, set on mouse move, we could basically pass it here. There we go. We can pass it. It fits in there. So you can define those as actual type. So that's very convenient as well, because you can avoid retyping the same thing many times, like you would often do in TypeScript. I guess you could define it as well as a type. I don't know. And Nim kind of seems a little bit simpler. A subtle issue with procedural types is that the calling convention of the procedure influences the type compatibility. Procedural types are only compatible if they have the same calling convention. As a special extension, a procedure of the calling convention, nimCall, can be passed to a parameter that expects a proc of the calling convention closure. Okay. So that's a special extension. So I guess this here has default calling convention is called nimCall. Okay. So that's something we should remember. Alrighty. And what does the closure do? So I guess this will be revealed right here. So Nim supports these calling conventions. nimCall is the default convention used for nimproc. It is the same as fastcall, but only for C compilers that support fastcall. I guess this is the way we are actually calling functions. I guess this could be, for the way, like, you can import, for example, C or C++ language code and define those functions there and call them. And I guess on different operating systems, you can call various things in different ways. Like normal nimcall probably would be just super optimized by a compiler to just work normal way. But maybe if you're calling some C++ code, or I don't know, yet something else, or maybe some kind of special system call, it needs to do something else behind the scenes. So I guess That's the reasoning here. Then we have closure. Closure is the default calling convention for a procedural type that lacks any pragma annotations. Okay. It indicates the procedure has hidden implicit parameter, an environment. Proc vars that have the calling convention closure take up two machine words, one for the proc pointer and another for the pointer to implicitly passed environment. So, okay, so this is basically, you know, when you're calling a normal function, like, hey, call this. Whenever was called in here, isn't aware of anywhere that was in the context of this code here. It's just completely separate, right? That's why you pass stuff by parameters. CPA needs to go. See you later as well. All right, take care out there. Alrighty, so when you call normal proc, you just call it, right? And whatever, like this on mouse move, it will be just called and just do stuff there. This code inside here is completely separate from this one here. While if you have something that's a closure and you actually define it as a closure, it will probably additionally have a reference to the stuff around it so that, you know, things can happen in some specific way. And I'm sure we're gonna get to that relatively soon because it's a specific subject. There are things like standard call. This is the standard call convention as specified by Microsoft. The generated C procedure is declared with the __ standard call keyword. So again, this is something behind the scenes, probably how C deals with stuff. C declaration. The C declaration convention means that the procedure shall use the same convention as the C compiler. Save call. Another Microsoft thing. Inline. The inline convention means that the caller should not call the procedure, but inline its code directly. Note that Nim does not inline, but leaves this to the C compiler. It generates the inline procedures. This is only a hint for the compiler. It may completely ignore it, and it may inline procedures that are not marked as inline. So yeah, just like in C++ or in C, it's just a hint. And then we have things like fast call, this call, syscall, and no convention. It generates C code, will not have an explicit calling convention, and thus use the C compiler's default calling convention. So this is needed because Nim's default calling convention for procedures is fast call to improve speed. So yeah, this half of it is just simply for various Microsoft weird stuff. Okay. Yeah, most calling conventions exist only for the Windows 32-bit platform. 32-bit platform, look at that. The old stuff. The default calling convention is nimcall, unless it is an inner proc, a proc inside of the proc. For an inner proc, an analysis is performed whether it accesses its environment. If it does so, it has the calling convention closure. Otherwise, it has the calling convention nimcall. Okay, so what it means is that, you know, let's say I write a proc. Print stuff. Okay, and we have X, Y, and Z, which are integers. Okay, nothing crazy here. And, you know, we could just have echo X is X, Y is Y, and Z is Z. All right. But maybe we just want to do first like let A is this, B is that, and let C is this. Okay, some random stuff. And then maybe for some reason we just needed to do some additional stuff. I don't know. We had a counter or something, var counter 0, and then we define proc print value, and it will be the value is, and maybe we want just to do something like counter value is bam. Okay. And we just need to remember to increase that counter. And therefore, we are going to do print value x, y, and z. So, I mean, this is completely unnecessary here. Or, sure, it's completely unnecessary, this part. But the whole idea here is that we can actually call it, right? Print stuff 1, 2, 3. We're going to run it. Invalid indentation. Oh, equals. There we go. We get 0 value is 1, 1 is value is 2, 2 is value is 3. So this will be called with a nim call, okay? Because it's just a normal proc. But here, this proc is inside. If we didn't, and we have this counter here, and this counter is outside of the proc, yet we are using it. Because if you have a proc inside another proc, you can just kind of bend those rules. And therefore, it figures out, you know what? This procedure accesses something here. Therefore, we need to make it a closure. Because it needs to, when this call happens, it needs to pass not only the pointer to this, which function it is, but also a pointer that kind of wraps all the other variables in this context. It needs to capture its environment. So if we wanted to make it into a nim call, we would need to probably take this and make it, count, and that'll be an integer. And if we pass it here, right, we'll make it variable so that we can actually edit it. There we go. And therefore, we'll just need to call it that way. Suddenly, this proc doesn't access anything outside of itself, and therefore the analysis will figure out that we just need to use nim call instead. So that's what it is. That's what happens behind the scenes, which means, a lot is happening behind the scenes. Okay, so let's leave all this super low level stuff for now, and let's move on to something else. In this case, the distinct type. It's something that I think shows up in every tutorial because it's a really pleasant feature that can save you a lot of problems down the line. Mostly, can save you time dealing with bugs. So, a distinct type is a new type derived from base type that is incompatible with its base type. In particular, it is an essential property of a distinct type that it does not imply a subtype relation between it and its base type. Explicit type conventions from a distinct type to its base type and vice versa are allowed. See also distinct base to get the reverse operation. So a distinct type is an ordinal type if its base type is an ordinal type. What a fun language. So looks like I won't have to go and explain it myself because there's this nice example of modeling currencies, which is, I believe, will be just perfect to show you the whole idea about those distinct types. So a distinct type can be used to model different physical units with a numerical base type. For example, the following example models currencies. Different currencies should not be mixed in monetary calculations. Distinct types are a perfect tool to model different currencies, right? We define type $, which is a distinct integer, and euro, which is a distinct integer. And even though this looks exactly the same, the whole idea is that this is different from that. It's completely different, cannot mix. So then we create a variable, D for dollars and E for euros. And if we want to print out D, which is dollars plus 12, it's like, nope, cannot add a number with, without a unit and a dollar. So that's the whole thing. It's not only that these two don't mix, this doesn't mix with just the integer either. So it's not like you can simply, you know what, I have 13 centimeters or like 13 feet or something, and I'm just gonna randomly add a number 3, because that number 3 kind of doesn't have meaning in those two, in the same context. So this is roughly the same thing. Unfortunately, the D plus 12 dollar is not allowed either, because plus is defined for integer, among others, but not for dollar. So a plus for dollars need to be defined. So that's the fun part. It's represented as a number in a background. It stores a number, but all the methods, all the procs and everything that was defined on an integer suddenly stopped working here. Which sounds like a headache, right? We need to define an operator plus for that adds a dollar to a dollar and returns a dollar, okay? And bam. And look how we're working with it here. We are using the plus operator, but for integer, we take the x, we turn it into integer, the same for y, and we add them to get the normal number, and then we take that number and put it back into the dollar. And that's how we can define a plus. It does not make sense to multiply a dollar with a dollar, but with a number without a unit, and the same holds for division. So, instead of doing dollar times dollar, which wouldn't make sense, we can just make it, okay, you can multiply by a number without a unit. And bam. The same thing is when you do the other way around. You define number without a unit times dollar, you end up with dollars. So you can multiply them. But this quickly gets tedious. The implementations are trivial, and the compiler should not generate all this code only to optimize it away later. After all, plus for dollars should produce the same binary code as plus for integers. The pragma borrow has been designed to solve this problem. In principle, it generates the above trivial implementations. Okay, so we can basically say, hey, multiply dollar with integer that returns a dollar, borrow. So, this kind of is a little bit confusing initially, because how does it know? We have the integer, we have this. So the borrow basically pretends that whenever you have dollar, that distinct type, it will just be boiled down to its base type, which is integer. So we have basically an equivalent of an integer, 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 okay? The same thing. It's actually exactly the same function for no reason. But it just generates the wrapper that has this definition, so we can do the things that we have to. Same thing for division here. That's that. The borrow pragma makes the compiler use the same implementation as the proc that deals with the distinct type's base type. So no code is actually generated. But it seems all this boilerplate code needs to be repeated for the euro currency. This can be solved with templates. Okay, so we can basically say that we have a template additive of some kind of type, right? We define out this type description, so we need to give it some kind of type. And then what it's gonna do is wherever we have typ, it's gonna replace it with a type. So we can do like plus, minus, and then the unary just to, I guess make sure that it's, if something is negative or positive. And then multiplicative, comparable, right? To define the comparisons and all this stuff. And then we can have the whole thing define currency, which takes some kind of type, and base, which is untype. And then we define type, distinct. Okay? And then we just call it, you know what, for define all the additive, all the multiplicative, and comparable procs for it. Bam, with borrowing. And this way, we can just define currency dollar. That behind the scenes is integer currency, which is also an integer. And bam, we can define many of them. And each one of them will have those specific, operations defined just within itself. So you still can mix a dollar with euro. The borrow pragma can also be used to annotate the distinct type to allow certain built-in operations to be lifted. So, for example, we have foo, which is an object that contains AB, which is integer, and some string. And we have bar, which is a distinct foo, so it's distinct type of this. But what we can do is we can borrow the dot operator, which I know that just sounds ridiculous, but this way we can actually do something like, we have the bar, which is BB. We can actually access the field. Without that, we wouldn't be able to access the field. I guess we could try to define our own, but I don't know how to define your own, access operator. I really don't know. You jump around memories or something? I don't know. So yeah, that's another thing. With objects, remember that you actually need to borrow the dot operator. I really don't know why it would be even thinkable not to do that. Maybe, I don't know. Alrighty. Currently, only the dot accessor can be borrowed in this way. So that's the only exception. Another example would be to avoid the SQL injection attacks. An SQL statement that is passed from Nim to an SQL database might be modeled as a string. However, using string templates and filling in the values is vulnerable to the famous SQL injection attack. So let's say we import a string utilities and define a procedure query. We give it the handle to the database and a statement as a string. Okay, so just run the statement. We create a variable username and we do db query select from users where name is, and this is supposed to be a spot that we're going to fill in through here. Okay, username. Horrible security hole, but the compiler does not mind. Okay, because the username could be a lot of things. If the username has something, drop table, semicolon drop table or something, we could be in big trouble. This can be avoided by distinguishing strings that contain SQL from strings that don't. Distinct types provide a means to introduce a new string type SQL that is incompatible with string. So type SQL is distinct string. Okay. Proc query, it takes the handle and a statement as SQL. There we go. Even though in the background it's, in the back it's still a string, but not everything will fit everywhere. So suddenly we can do this. Static error. Query expects an SQL string. So yeah, first of all, this operator wouldn't work to, combine them. Second, in this case, this is a SQL, string, and this is a string. Everything is string, so this won't work. It's an essential property of abstract types that they do not imply a subtype relation between the abstract type and its base type. Explicit type conversions from string to SQL are allowed. So, you know, we can do, I don't know, proper quote, right? That takes a string and returns SQL. Quotes a string properly for an SQL statement. So it just, you know, I guess it would do it here. But also, hey, turn it, basically take that string and turn it into SQL. And we define a proc, which will be format SQL, and then the values, open array of strings. So suddenly, quote each argument. Bam, value map it, run the proper quote over it, right? I mean, it's not implemented here, but do it. And for each element, then it basically runs the normal thing, but only on a sequence of those strings that were properly escaped. So now we can run this .sql and bam. And I think what we could do actually is do a little bit more fun thing. Something that we learned before. So in here, we could, I believe, define. Wait, where did we define this? We don't have the SQL defined here, right? There we go. Query itself. Yeah, we need that too. Yeah. So let's just plop the type here. The query will be defined here as taking SQL, while the username will be down here. So that it all makes sense now, okay? So the thing that we could do here is also do proc SQL, like lowercase SQL, and I will take string and return this, okay? This is just to mark that this string is an actual SQL, okay? So because we just defined this proc, we can actually do, instead of this thing, .sql, we can just do SQL. And there's no space here. That means that this is an SQL string literal, and therefore will turn into SQL, and therefore the proper operator will be run. So yeah, but again, if you remove that, the query will fail because it expects an SQL. So I should be able to run it, right? Invalid indentation, where? Probably here. 11. Oh, of course. Echo statement. There we go. What's going on? Undeclared identifier, DB handle, string, whatever for now. So we can just have a break. A database, right? Echo statement SQL. We'll go for args type this. Nim 10. Of course, statement dot string. Because we need to print it out, we need to go the other way around. Okay, and now it worked. So this way we just basically made our string literal that we can mark something as an SQL. So we could basically make the for statement is this here. And that already is an SQL, and therefore we can just do like that. That's it. I really like the idea of those little things. It's kind of nice. Especially that we could do additional logic there, not just to convert it directly. Because we can still, you know, do the search for some keywords maybe that we don't want in there, or something or something. So that's the whole idea here. Alrighty. We go through that. Now we have compile time checking against SQL injection attacks. Since this, the string.sql is transformed to SQL, no new syntax is needed for nice looking SQL string literals. The hypothetical SQL type actually exists in the library as the SQL query type for modules like DB SQLite. This is awesome. We're gonna finish early today because Oh, hello, Taras. How are you doing? And hello, AI Resistance. We've got some Twitch and YouTube viewers coming on at the same time. How are you guys doing? So let's do auto type. The auto type can only be used for return types and parameters. For return types, it causes the compiler to infer the type from the routine body. Okay, this way we don't have to specify it ourselves. Sure. For parameters, it currently creates implicitly generate routines. So this is basically the same as defining that, these could be two different types and whatnot, and just run it. I don't know, I kind of like doing that, but maybe I'll try this out a few times in areas where it doesn't matter too much, where, I'm feeling like, okay, this could use some lax rules. I don't feel like typing this whole thing out every time. So why not? Oh, it's you on YouTube. Huh. Interesting. Didn't you join in last time as somebody else? Oh, this might be your different account. Okay. Do you want to see my Brain F sheets? What do you mean by sheets? Oh, wait, did you actually go and implementing spreadsheets in Brain F? What the hell? Sure, send over a link. I'll take a look. This sounds like... Oh my goodness. Yeah, spreadsheet processor with Brain F as formula language. And you're getting... commented... Oh, the links. How on earth did I... Maybe you can help me out. How do I do it on Twitch that somebody can send a link? Because that would be interesting if I would be able to just specify one person that, hey, you can send links or something. I couldn't find that quickly during last stream. You even got a whole domain. Why not? Let me just make it as a new tab. Okay, we got spreadsheets. And I know nothing about Brain F. ABC. Let's do 1, 2, 3. Right? 4, 5, 6. And equals. And what the hell do I do here? Yeah, this isn't happy. First cell hello, second cell world. Okay. So let's do hello world. I'm getting material design vibes. Okay. I'll get rid of the lack of exclamation mark. What do I do next? Oh, wow. Okay. Wait, these aren't even normal things. These need to be actual specific arrows, right? Okay. We have triple L. I must say, I have no clue what's going on here. These are two repetitive things. Take first cell, take second cell. No, I don't know. I don't know what it means. What if I'm gonna copy this? Nothing. What if I'm going to do this? Nothing. What if I'm going to do this? Nope. I don't think I'm gonna be able to figure out the syntax because it's world hello. So this is go 2 to the left, take the code, go to the one to the right, and take the code. Oh, I see. So I will need to do this and print it out. Will be hello. And then I'm gonna... How do I print out a space? I guess comma is the next instruction. And this would be... Yeah, just concats two strings. Yeah, you can type these marks with Control Alt and arrow key. Oh, interesting. Control Alt. Ah, never thought that there's a shortcut. Thank you for that. Oh no, that's probably a shortcut you added here. Yeah, that's it. You added a shortcut because normally that doesn't behave that way, right? Yep. So we've got this one, and I wanted to insert a space here, and I don't know how to code a space in BrainF. So yeah, I would need to grab this, put a space here, right? Space bar. There we go. So I would need to go here, print this, then go to down, print it, go up, up. I'm gonna write right up and print it. Whoa. I messed something up. So I wanted to print hello, space, and then this one. Don't know. There's some bugs. Sure, but wow, you actually made interpreter, or did somebody made interpreter for BrainF that you just reused, I presume? Oh, use Flutter. Okay, Dart, of course. And Dart compiles down to JavaScript, I presume. So, wow. That is interesting. Never touched Flutter. I think I kind of touched it when they announced it, and then I was like, you know what? I'm too inexperienced to understand anything. But hey, amazing. This is not a trivial thing to make. So, yeah, interpreter is the easy part. Okay, sure. New row, first cell, 1. Okay, we're gonna add. And second cell will be 2. And then we're gonna have a very interesting function to compute to 3. Doesn't mean there's like 32 of them here to just skip zeros or something. That's an interesting, because I'll remove 1 and oh. Okay, that's a different operational numbers where minus decreases it, plus increases it. Oh, that's BrainF for you. This is the converse ASCII to number. Okay. Wow. First or second numbers. So we're gonna change to 6. That works. To 10. And that should break, right? Yeah, because it'll be 1. Mm-hmm. And yeah, then we just try and we just make the different operations on numbers. On characters. Okay, sure. So yeah, we're just not operating on numbers. This doesn't have concept of numbers, I presume. Yeah. Well, you could include that as a part of some kind of enterprise, product. Like, you know what, this has included scripting and this and that, and you can be sure that somebody would actually do something like that and start using it to some wild extent. Just like people do with Excel. That's awesome. You'll add more stuff later. Well, that's gonna be one of those fun websites you can just post somewhere and people, for some reason, really, really, really like. Okay, so people could contribute functions. Look at that. Yeah, go for it. That'll be awesome. Where did my Nim go? Language manual, and we get back to, what was it? Auto type. Okay. Yeah, I think I will be finishing here. However, later versions of the language might change this to mean infer the parameter types from the body. Then the above foo will be rejected as the parameters types cannot be inferred from the empty discard statement. Ooh, that would be really nice if this was implemented. Very nice. I would like that. Even TypeScript can't do that right now, I think. Have you seen UI UA language? I have not. Let's search for it. Wiwa. Ooh. Okay, somebody actually went to an extent to make it work. Really? I guess this is one. This must be for, I don't know. Maybe I'm just the person that prefers to make things that kind of work. I mean, this works, but who would use that? Come on, bracket, fork, under, both. So, okay. Wiwa. Okay, I won't say it the way it's. Wiwa. It's a general purpose, stack-based, array-oriented programming language with a focus on simplicity, beauty, and tacit code. Wiwa lets you write code that is as short as possible while remaining readable, so you can focus on problems rather than ceremony. Not sure about that looking at this so far. The language is not yet stable as its design space is still being explored, however, it is already quite powerful and fun to use. We have... Okay, so this actually tries to explain everything to you. So, reduce. Apply a reducing function to an array. So I guess this is an array. Reducing function. Add values, duplicate the top value on the stack. Okay, so this is purely stack based. Okay. Get a number of rows, an array, sub the top two values on the stack, and divide values. Oof. Oh, we've got a bunch of examples here. I don't think readable is the really thing here. But wow, kudos for the person. Wow. Well, let's go from the beginning. So reduce, apply a reducing function to an array. By reducing function, what do you mean? How does it work on an array? Then add and flip. Okay. Swap. Product, range, reshape. So this is 234. Because this is not an array, right? Multiply values. Make an array of all natural numbers less than the number. Why is that a specific function? Okay, let me read up your comments. It is not BrainF related. It is supposedly very good language. Really. My brain hurts. Probably more than from BrainF. Unabashedly, I'll utilize arrays. Not equals to space character. Oh. Okay, I guess add is to character and then something. Okay. Then duplicate the top value of on the stack and then group sequential sections of the array. Get the first row of an array. Ouch. Click to run format. This is nuts. The shape. Make an array one-dimensional. Table. There are actual words here. So that means there's more than this. Apply a function to each combination of rows. Keep not member. Oh my goodness. How do you generate images? RGB is constant. Transpose, rotate the shape of an array. This is rather weird. Somebody actually did a lot of time here. Put a lot of time into that. Examples are super bad. You should click hash sign. On the top right when there is words. Hash, comment. I mean, that adds the comment. Not sure which hash you're talking about. Top right. As in run. Oh, okay. Wait, what? Click run to format. Arrange to make 3 copies. List 3 products. Run. Oh, okay. I see. Ah, okay. So basically, all right, the shape table, so you can type it in normally and then it just compresses it into funky little characters. I mean, it's hard to understand anything at all. I won't even attempt to try to understand that. This probably does a lot of stuff with math, and unfortunately, I'm really bad with math. Has experimental support of calling functions from shared libraries through FFI. Wow, okay. Has language server. Rust interaction. Integration. Spawning threads, interacting with... What? Language tour. This hurts my brain that... Because this is clearly not just one person. "71 contributors. I will need to investigate that because this is... So, WiiWire is a contender for next spreadsheet processor. Considering it's that popular, and it's clearly not just a joke, then wow. Wow, okay. So yeah, array programming and stack based. Okay, I'm impressed. I did not expect a language that actually is like that and actually... I don't know. So, stack based? Bunch of constants, of course, already as characters. Because why not? They're totally not gonna get mixed in with all this stuff. Monadic pervasive, okay. Dyadic. Okay, so this is math. Basically math and for language researchers. Not for mere mortals. Aggregation, planet, advanced stack manipulation, identity, gap, dip, both, fork. Discard the top stack value, then call a function. Do nothing with one value. Comp time. Run a function at compile time. Why not? Oh dear. This is nuts. Taras says, I couldn't believe my eyes and spreadsheets. Yeah, this could be pretty good for our spreadsheets. Definitely. At least it would look pretty if you would be able to actually implement all the fancy colors. Something tells me this whole editor is actually in some way embeddable. On. Run. And replaces it, of course. And I guess you can't name variables or anything because, I mean, one of them had kind of variables or something. But still, I'm impressed, but I don't like it. So that's that. Alright, so that will be it for the Nim Manual for today, as I am not feeling like reading more of that. My brain is kind of weak today. So... oh yeah, that was fun. Thank you for sending those links. I was curious about those weird things going on. Yep, it's been a long Friday. That's for sure. Alright, so that's that. I was thinking maybe doing a little bit of... what do you call it? coding with Raylib, but I think I'll pass on it. And I'll just enjoy weekend for a change. Because it's been some time since I had, like, weekend where I don't have to do anything. So I'll say my goodbyes. And, thank you for sending those links. It's always fun to check something out. And for everyone who enjoyed the content, and I mean mostly the going through the Nim language manual, consider liking and subscribing on YouTube. Consider following on Twitch. And I'll see you on Monday where we'll do more game development. Don't know if it will be Raylib or Unreal for Nim for Unreal Engine yet. So we'll see how that goes. So again, thank you and see you around and have a great weekend, everyone.